Good day. Today's topic is IoT applications in the domain-specific IoT and the models and envisioning smart airport using IoT. So, what is this envisioning smart airport using IoT? So, it is the problem with the traditional airports, like for example, you might have seen long queues, check-in delays due to that, and security issues, and boarding. All because of the long queue, you face a lot of issues like wait times at the app. So anxiety, where is my luggage? Those kind of things will as a result of these things. And delays and lack of information unclear why a flight is delayed, and sometimes inefficient operations, high energy costs, cleaning schedules not optimized, and navigation difficult to find gates, amenities, etc. And like the big picture in the airport is something like an airport is a complex, time-sensitive, mini city. Inefficiencies here have massive economic, operational, and customer satisfaction repercussions. And solution to this problem is like we can transform this ecosystem by making it data-driven, connected, and intelligent using IoT. So, what is IoT in this context? So IoT is the network of physical objects, things embedded with sensors, software, and other technologies to connect and exchange data with other devices and systems to over the internet. And core components of the IoT stack are sensing layer, network layer, data processing layer, application layer. Sensing layer RFID tags, CCTV cameras, LiDAR, temperature or humidity sensor, beacon, GPS. Network layer, Wi-Fi, 5G, LoRaWAN, Bluetooth, etc. And data processing layer like cloud platforms, AWS, Azure, fog edge computing, and application layers like mobile apps, dashboards, automated systems, etc. And the smart airport ecosystem and IoT-driven transformation. Let's break down the airport journey and see how IoT intervenes at every step. See, journey to airport, pre-book, traffic, parking, etc. are the main issues or pain points. And to overcome this, spot parking sensors detect free spots, app guides drivers, the traffic flow analysis cameras and sensors feed data to predictive models, and network data and analytics and app dev are related to this computer science. Check-in and baggage drop. So pain points are like long queues, auto check-in kiosk, and biometric smart baggage, traffic RFID tags on luggage, passengers track bags via an app in real time, RFID take like database management and security, and also security and border control. In this, you'll have a bottleneck intrusive. These are the pain points, and IoT solutions for this is like smart security lines, sensors detect view length, redirect passengers, biometric e-gates, facial recognition for seamless access, and computer vision, AAML, data privacy, etc. And indoor navigation and retail, getting lost, missing flights, indoor GPS using BLE beacons, personalized directions to gate by a mobile app, location-based promotions, beacons push offers from nearby shops, mobile computing networks, etc. And baggage handling like lost luggage, mishandling. These are the pain points in an airport. RFID scanners at key points, loading, transfers, arrival, system alerts if a bag is routed incorrectly, and sensor networks, real-time systems, or things related to computers. And aircraft turnaround is one issues. Like in these pain points are delays and inefficiencies. IoT sensors on ground equipment, fuel trucks, baggage carts report status, predictive maintenance such as sensors on jet bridges, trucks, predict failures, etc. And computer science related stuffs are embedded systems and predictive analytics. And facilities management, high energy costs, cleanliness, smart lighting, and high HVAC, motion and occupancy sensors, optimized energy use, smart waste management, bin sensors alert for clearance, water leakage detection, sensors in pipes trigger early alerts, and embedded C, cloud computing, etc. So, to take a deep dive, the role of data, AI, and cloud, the cloud's the main for this particular IoT area, because that's where the data are stored. And data is the fuel. All these sensors generate terabytes of data. Cloud is the central nervous system like AWS IoT Core, Azure IoT Hub. They ingest, store, and process this data at scale. And AI/ML is the brain for this, like predictive analytics, anomaly detection, computer vision, digital twins. In the predictive analytics, predict passenger flow to optimize staff scheduling, anomaly detection, identify suspicious unattended baggage, computer vision, analyze CCTV feeds for security threats or queue management. Digital twins create a virtual replica of the airport to simulate scenarios and optimize operations. And architecture diagrams draw on board sensors and actuators, edge gateway, fog computing, cloud platform, AI/ML analytics, application, apps, dashboards, and automated actions. Challenges and considerations for CSE engineers, like security. A hacked airport is a nightmare. Secure device identity, encrypted data transmission, and regular patches are critical. And privacy, biometric and tracking data must be handled with strict governance. Example GDPR, interoperability, devices from different vendors must communicate seamlessly. Standardized protocols like MQTT or key, and scalability and reliability. The system must handle peak travel times without failure. Data overload, filtering, and processing relevant data at the edge to avoid cloud bandwidth costs. And in-class activity, the IoT design sprint, these kind of examples you can do. Exercises like task divides to we can have a class divided into 4 to 5, and each is an IoT solution startup kind of scenario, where in the startup, this is a scenario. A major international airport has hired to solve one of these two problems using IoT. One is the panic passenger. The passenger's flight is at distant gate. They are running late. The mystery delay, a flight is delayed, but the airline staff cannot immediately determine the root cause. So, what are the deliverables in this? Like solution name, list of IoT sensors, device pieces used, data flow. How does data move from sensor to actionable insight? End user interface. What does the passenger, airline staff see? App, dashboard, etc. And conclusion and key takeaways, IoT transforms airports from reactive to proactive and predictive. It creates a seamless, efficient, and secure experience for both passengers and operators. For CSE students, this domain offers challenging problems in networking, data science, cloud computing, security, and software development. The future is hyper automation, where IoT, AI, and robotics work in concept to create a truly invisible and efficient travel experiences. And further readings and resources or case studies, technology providers like you can check those websites, company websites, and video and connected artworks by various tech companies available on YouTube. So that's all about the envisioning smart airport using IoT. Thank you.